Okay, so in this video we're going to talk about completing the square and actually what's called vertex form. But before we do that, we're going to talk about these things called transformations. And we've seen this before where graphs flip or move. So you've seen a little bit of this in your geometry courses, and we've talked a little bit about this in our class. So I've numbered all these items to the left, 1, 2, 3, and 4. And so we have this notation where I have A in front of f of x, was just an equation or function, right? And then I have an a inside the parentheses with x, and then I have this k, and then I have this k right here. I'm actually going to change this to an h. So let me go ahead and clean this up a little bit. And we'll make that an h. Okay? And so we'll talk about each one individually, and then as we do some of these problems, I'll identify what type of change is occurring. So the idea here is we can have a vertical stretch. So if we have a vertical stretch, and what's hard about parabolas is, for number one, an example of a vertical stretch would be 3x squared. Okay? Now 3x squared is a change from what's called its parent function. And so because we have a number in front of x squared, it's going to cause some sort of vertical stretch or compression. And so if it was a compression for this, a compression, A is going to be less than or equal to 1, but greater than or equal to negative 1, or excuse me, but greater than or equal to 0. And actually, I apologize, not equal to 0. Because if it was 0, it would just be a point. And so compression, basically, when we look at this, it's going to be a fraction that's less than 1. Okay? And if it's negative, we know that that causes the shape to reflect over the x-axis. So what's difficult with parabolas is to see what's happening in the graph. Because if I was to draw a generic equation for x squared, it would look like that. So x squared's in red. And 3x squared, we'll go ahead and we'll put it in blue. And what it's going to look like is this. And it looks like it shrinks in the x direction. So it looks like the graph is pushing in this way, but what's actually happening is it's stretching up. And what we'll do is we'll compare values in a table to show you exactly what's happening. And what we want to look at is the y values. And so if we look at, if x is 1, we're going to get 1 here. If x is 2, we're going to get 4 here, right? Well, if x is 1 here, what are we going to get? 3. If x is 2, what are we going to get? Well, 2 squared is 4. 4 times 3 is 12. So what happened to the y values? Because those are increasing, we call it a stretch. And so that's why when we have a number in front, it's some sort of stretch or compression vertically, because the y value is changing. Okay? And so that is a vertical stretch or compression. Okay, so in this one we're going to talk about a horizontal compression or stretch. And so on the previous slide, we saw that the way it looked was when we had some function where the a was on the inside with the x. So the way that this might look would be 4x quantity squared. This one, if I was to graph it, here's the parent function, x squared. And what's hard about this one, and then here's 4x squared. It looks the same as the other one, and that's because of the behavior of the parabola. So this is the graph in black. And that's why it's hard to distinguish when we look at a picture of a parabola between the horizontal and vertical compressions or stretches. So the idea here is, what we look at is, where is that a value? Is it inside the parentheses with the x, or is it outside being calculated after we perform the square on the variable? This one we're multiplying x by some number, so I know it's going to be a horizontal change, and that's kind of the trick to determine which one is which. And then this one is outside of the function, so it's going to be a vertical change. Okay, and same rules apply. If this guy is a fraction greater than 0 but less than 1, it's going to be a shrink. If it's greater than 1, it's going to be a stretch. And same thing with the vertical. Okay? So the next thing that we're going to talk about is we're going to talk about the idea of a parabola moving left or right or up or down. And so we have our equation, and if I put a plus k, we saw in one of our videos that if we think about this in standard form, this is what actually changed the y-intercept. So plus k is going to cause the graph to move up or down. So if I had x squared plus 3, let's look at the difference between x squared plus 3 and x squared. So if I graph x squared plus 3, it's going to move up 3 units. If I graph x squared, it's going to be centered, or the vertex is going to be at the origin. So notice this guy shifted the graph up 3 units. And that's what that number at the end, or k, is going to do the equation. And the other one that we had is f of x minus h. So to create a quick equation here, if I had x minus 4 quantity squared, now you can graph this, and we're going to compare it to x squared. So if I do x minus 4 quantity squared and compare it to our parent function, which is x squared, so this is what x squared looks like, I'm going to actually show you the graph first. It actually moves backwards. And the reason for that is we want to know what the x shift is. And so in order to determine what the x shift is, we take what's inside the parentheses, set it equal to 0, and solve. And I actually graphed it wrong, so let me go ahead and rechange that. It's opposite of what you see. So we have 1, 2, 3, 4, and that is what our graph is going to look like. Okay, so we set it equal to 0 and solve, and that tells me I'm going to move over 4 units in a positive direction. There's going to be an activity with a discussion with graphing where you guys manipulate. They're not going to be parabolas, but I want you to see how the changes occur in a function that's easy to determine, whether it's a vertical stretch, compression, horizontal, and whatnot. Okay, so these are all the different types of transformations that occur, and in our videos I'm going to make sure that when we see something in vertex form, I'm going to go ahead and go through what each one of the changes are. Make sure that you are aware of what specific number causes what type of change based on where it's located in the equation.